right, we just went over the A problem. Let's go over the B problem for this. So looking at this, we got, let's look at the degree of this. We got a degree 3 down here, all right? And then here we've got degree 2 and then another one. These are equal degreed. That means that the horizontal asymptote is going to be the ratio of the coefficients here. Again, and we got a 1 and a 1 out in front. So it's going to be at y equals 1, just like the last one. That's going to be our horizontal asymptote. And then our vertical asymptotes are going to happen. We look at the bottom and we say what values can't be equal to 0. And here's the thing, they're repeated down here. So at -3, so at -3, that's a vertical asymptote. And it just has like a higher degree there. So it means like that one gets used, you know, multiple times there. So there's going to be other stuff that happens though here. Look at the top to get the x-intercepts. Those are the zeros up top. Now there were none of these removable discontinuities. There's nothing that cancels on the top and the bottom like the factors that cancel here. So there's going to be no holes in it. But the x-intercepts are going to have something interesting that happens. There's an x-intercept here at 0, at x equals 0. And with a multiplicity of 1, and at x equals 1 with a multiplicity of 2 means that there's a bounce there. So let's look at that. So 0, so right here, there will be a point at 0 where there's an x-intercept. And hold it, if there's an x-intercept there, that means that that's also where there's a y-intercept at 0. All right, that is the only other place. And then at 1 here, there is a bounce. So it's going to go through that, but there's either going to be a little bounce below or a little bounce above. I'll do that in pencil because I don't know, you know, the graph is going to go through this point and go to that point. And is it going to like, I'll have to have a little bounce above it or a little bounce below it? It's a question to be determined, but it's this tiny, silly little bounce. All right, so whew, boy, oh boy, how do we graph the rest of this? Remember, we make a little x and y table, and so and we test some points. Remember that I like to test 10 and I like to test -10 because they're kind of like further away from here, and 10 is a relatively nice number to put into this stuff. And then when we're looking at this, I'm going to want it so that test the going out to infinity. I need to test a point that's kind of close to this -3 line, but a little higher and a little lower. So let's test -2 and -4. So -2 and -4, and we'll get the general behavior of this. In the last video, I kind of like did each point and then plotted them. Let's do each point, all the points, and then get like the what are the values here. So 10. We're going to do 10 minus 1, which is 9, and we're going to square that. That's, you know, that's 81. 81 times another 10 is going to be 810. Okay, let's just bank that. And then on the bottom here, we're going to have 10 plus 3. 10 plus 3, that's 13. And we're going to be cubing that. So I'm going to be dividing this by 13 to the power of 3. Ugh. But we get that 0.37. So we get 0.37. Let's do the same thing, but with a -10. So up top, we're going to have -10 minus 1, which is -11, and we're going to square that. That's 121 times another -10. So it's, let's see, that's negative. No, but it gets squared, and so it's positive. But then times a -10, so that's -121, but then with a 0 at the end of it because of that power of 10. On the bottom here, we're going to have -10 plus 3, which would make -7, but we're going to cube that. -7, so 7 times there. So let's not worry about it. We got -7, that gets to the power of 3, that's getting cubed. All right. Technical things here is that the negative is also getting cubed. So let's go with that. Okay, so we had a negative divided by a negative, so that gives us a positive 3.5, so 3.5, we're getting there. -2, gotta pop that in, so -2 minus 1, which would be -3. -3 times itself makes 9, but then 9 times a -2. Let's see, 9 times, oh my god, my brain's not working, but yeah, -18. -18 gets divided by -2 plus 3, which would be 1, and 1 cube, 1. So -18 divided by 1, which is negative 18, great. Negative 4. So negative 4 minus 1 is going to be negative 5. Negative 5 squared is positive 25. So we're going to have 25 times a negative 4, which is negative 100. Negative 100 then gets divided by 4. So negative 4. So this is going to be negative 1 cubed. Negative 1 cubed means that it's going to be a negative 1 at the end. So divided by a negative 1, it's a positive 100. Holy moly. Okay, so let's, all right, so we got some interesting stuff here. All right, let's start off with that negative 4 and 100. So if we go back to negative 4, we're gonna have a height of 100. Whoa, that's like way off the graph, okay? So wherever that is, it's gonna be way off the graph. Negative 2. So negative, well, let's work with that negative 10. Negative 10 is gonna be at 1, 2, 3.5. So it's gonna have a height there. So what we're seeing is that our graph is, it's gonna do something like this, okay? All right, here, and then by the time we get to negative 10, it's gonna be that height, and it's gonna be swooping like that, all right? It's not gonna cross over and do anything crazy, because there aren't any other zeros that it has to touch over here. Now let's go to that negative 2. So at negative 2, the value would be at negative 18. That's way down there, way down there. Now that's gonna have to eventually come up and connect. So it's eventually, let's see, it's gonna have to come up and connect with this 0. All right, now that's going to cross over, since it's a multiplicity of 1. It's gonna have to cross over and then help to do a little bounce off of this. So I know the bounce is coming from the top because that one was multiplicity of 2. And then as we go to positive 10 all the way out, doesn't quite get to a height of 1, it gets to a height of 0.37. So this then, it's going to then arrow up just very slightly, getting closer and closer to that. So that's going over this problem. All right, see that little table? That's an important way of how to find the end behavior for this. All right, let's go to the next one, C.